We are recording on YouTube. So welcome everyone to this month's Eastside AI, ML and IoT meetup. This is for folks who are fans of Internet of Things, machine learning, AI, together, have a bit of fun. In fact, we've rebooted this months ago, had some few great speakers. We just want to keep growing this community, just keep bringing folks together who are interested. Now, these communities, they only happen when everybody's involved. So if you want to get involved, if you want to speak, you've got something you want to talk about, please let me or Andrew know, and we'll get you up here to share what you've got with the world. If you're a first-time speaker and you've never spoken at an event before, but you want to give it a try, but you're nervous about it, then again, let us know. We are seasoned veterans. I think my biggest audience is about 1,500 people. So, any help you need, we can help you. If you want to just do like a 5-minute lightning talk, we can support you with that. So whatever you need, if you want to get up here and share the cool stuff you're doing with the world, we'd love to have you. Now, we need to start all our events with a code of conduct. This is the Microsoft Reactor, and therefore we have to follow the Microsoft Reactor code of conduct. And these events that we have here, we seek to provide a respectful, friendly, professional experience for everyone, regardless of gender, sexual orientation, physical appearance, disability, age, race, or religion. And we do not tolerate any behavior that is harassing or degrading to any individuals. We have a zero tolerance policy. If anyone does anything that makes you feel uncomfortable or there's a breach of a code of conduct, let me or Andrew know, and we will get the situation resolved. If you do breach our code of conduct, you'll be kicked out of this event and then banned from all future events at any Microsoft venue. We take this very, very seriously. Now, before we kick off, if you've not come to the reactors before, hello, computer, we have a little video that just sums up what the reactor is all about.
Do you suffer from dreary meetups? Do you have aches and pains from uncomfortable events? Can you not afford the bills from expensive venues?
Hi, I'm Jim Bennett. You may know me from shows on Microsoft Build, Channel 9, or Learn TV. I'm your Reactor Cloud advocate here in Redmond, and I'm here to talk to you about how Microsoft Reactor can alleviate your symptoms. Roll the tape.
Welcome to Microsoft Reactor. We give developers a space to come together to meet, learn, and enjoy the latest technology. With 12 locations around the world, Reactor is never far away, and your home for meetups, conferences, workshops, and any free and open event. You bring the community, we do the rest. Now back to Jim in Redmond.
We have reactors in versions that suit you. Here's our Redmond reactor with plenty of space for your events. Microsoft reactors can be arranged according to your needs. We have enough screens all the way along to help reduce eye strain. We also have breakout rooms for those that might find the main space too large or overwhelming. Microsoft Reactor is also right for you if you're at home. We record and stream your events, so your community members who can't be here in person can still join in. Microsoft Reactor is also available in smaller sizes. Microsoft Reactor is now available in our new Fun Zone packaging. Microsoft Reactor is available now all around the world. Ask your community leader or email reactor@microsoft.com to find out if Microsoft Reactor is right for you.
Microsoft Reactor is free treatment for dreary events and is only suitable for free community events that are open to everyone. Side effects include learning, growing, networking, making new friends, exposure to new technology, and possibly even some pizza and swag. Always read the code of conduct.
So yeah, if you are a user group leader, if you run your own meetup, want to use this space, you can. It's free and available to you. The only requirement is your event that you run is free and available to everybody. We don't allow any paid for events, and we don't allow any closed events. Obviously, if it's like a student event, your audience is only students, that's fine. But yeah, this is designed for free and open events. If you want to use it, just get in touch with me. And don't also play YouTube. Stupid thing. So if you want to use the space for your own events, then please let me know and we can organize that. And with that, it is time to hand over to our speaker. Locksley has been a regular attendee at these events and kindly volunteered to give a cool session today involving custom vision. So quick switch over and then I'll hand over to you.
Awesome. Thank you so much, Jim. I absolutely loved that Microsoft Reactor video so much. I hope that my talk brings the same smile to your faces as that video brought to me. I literally spent that 2 minutes just like smiling and laughing. So hopefully, also, where's my free Clippy cameo? I should have asked for that before I came and gave this talk, but it's chill. But thank you so much for setting up my computer, Jim. And we are about ready to get started. And our talk today is anyone can AI with Azure Custom Vision. And I think like this meetup in particular, like something like AI can feel like a very difficult topic to break into or create your very first project about. But the cool thing is, like today, I'm here to share with you this companies like Microsoft have created services that make like the barrier to entry for AI much easier, which means if you're a student and you've never used AI before, then this tool might be your very first introduction. And I promise you, you can figure it out. And although I'll primarily be sharing fun projects that I've just created in my spare time because I found them interesting, I have worked on projects in industry where they are using tools just like Azure Custom Vision and sometimes even using Custom Vision to solve some of their company's most important AI-related problems. And with that, let's head over to our next slide. So, but also in addition to this being anyone can AI with Azure Custom Vision, it'll also be an unexpected lesson in ornithology. So what the heck is ornithology? That is the study of birds. So you're going to go AI, but also you're going to hopefully walk away from this talk knowing a lot more about the birds that are local to the Pacific Northwest for us watching this in the Redmond area, but also some birds that are a little farther away from us. So hope you enjoy it. I think it's a pretty fun talk. But before we go into that, let's learn a little bit about who am I? And so this is a little bit about who I am. So I'm currently, I'm the TechTogether Program Manager at Major League Hacking. What is Major League Hacking? If you have attended a hackathon, it is probably partnered with Major League Hacking to make it the most successful and well-run event possible. And as the TechTogether Program Manager, I have the extremely unique privilege to specifically help focus and support and grow their gender-focused hackathon. So bringing more women and gender marginalized people into the hackathon space and in extension, the tech space. So in addition to that, that's my day job. Outside of that, I'm also earning my Master of Science at in Information Management at the University of Washington. For those of you who studied informatics or are part of the iSchool is my school. We're here representing. And then finally, last but not least, outside of all of that, I also am a hiker and mountain climber in the Pacific Northwest. Like my claims to fame that I always tell people about is I climbed Mount St. Helens literally a year ago. This year, yeah, woo, I'm so hyped. I want to do it again. Outside of that, also my big thing this year was doing the Enchantments 20-mile through hike right outside of Leavenworth. So if you also like talk to me about hackathons, talk to me about master's programs at UW, talk to me about AI, but also I like talking about hiking. So obviously, any questions on those, happy to answer. Okay, but that's enough about me. Let's go into the actual meat of this presentation, and that is what is custom vision. And like, if you know me, I make this mistake all the time where someone's like, yo, we want to use AI and images. And I go, custom vision. But that's not the actual name of the technology. That is the Microsoft Azure name of the technology. It's actually computer vision. What is computer vision? So computer vision is within this huge world of AI, artificial intelligence, we've got computer vision. And that is the specific area where we take images and the AI is trained to be smart enough to identify patterns within those images. So for an example, how do we get self-driving cars to drive and not crash into other cars? How do we actually get facial recognition to work? These are all applications of computer vision. And custom vision is Microsoft Azure's low-code way to get introduced to this computer vision space and to really detect images. So, and the link that you can use to navigate to this is customvision.ai. And how does this computer vision, custom vision work? And this is kind of like a very simple example of how a lot of AI works. And the first is inputting data, probably one of the most time-consuming processes if you're getting involved in custom vision for the very first time, is finding a bunch of data and then inputting it. Even one thing that custom vision says when you go to and learn about it for the very first time is like, we don't provide you existing data sets because that's where the custom part comes in. It's where any person in the world can create their own custom data set and train an algorithm based off of that. After you find the data, you then have to analyze it. So make those initial kind of connections between this type of image represents that. Then you plug and chug it into custom vision. And that's where it finds patterns and figures out where are their connections. So then you can later make predictions off of those existing training. And then this is where I think the true magic of custom vision comes in, is we have an opportunity to then continuously train the custom vision to make it even better. So if it starts to get stuff wrong at the beginning, you can continue to store feedback and improve it over time. That is one of my favorite features in Azure Custom Vision. What are we exactly going to test custom vision with today? And that's where our unexpected lesson in ornithology comes in. We've got 4 different types of hummingbirds on the screen that we want to figure out if custom vision can recognize these different species. And now as humans, how do we recognize the different species of hummingbirds? And that's typically by identifying the coloring all over, but also the pattern and the color of feathers on the male species throats. And we have 4 hummingbirds that are native to the state of Washington. The first is the calliope hummingbird, probably my favorite on the list because it's got this beautiful like starburst of like feathers on its neck, which I just find absolutely gorgeous. Next up we have is the black-chinned, which is unique on this list for having very purple feathers on its neck. We then have the Anna's, probably the one that you've seen the most, probably. And then last but not least, we have the Rufous hummingbird. And this is my one area in the talk where I'm going to ask for some audience participation. Which of these hummingbirds have you seen before? I'm really just genuinely curious here. Yes, go right ahead. That's amazing. I love it. Anyone else who's seen any of these hummingbirds? Yes, go ahead. So cool. Oh my gosh, that's amazing. Anyone else who's seen hummingbirds? Yes. Mm-hmm. Yeah. Yeah. Mm-hmm. That is amazing. Hopefully, after this talk, you can look in your backyard and go, oh, yeah, I know exactly the type of hummingbird that is in my backyard. Even like personally, I had a biology teacher in high school who had seen the Annas and Rufous hummingbirds before, but he also was like a photographer. So we could get these really high def images of these. And that's like my future goal is to buy a really nice camera and actually take pictures of these hummingbirds and train the algorithm based off of my own pictures. For now, we're just pulling them off of the internet. But even another fun fact here is I first collected all of these pictures like 2 years ago. And at the time I was aware of like the Annas, and that's the only hummingbird on this list I've ever seen. And I came back to this and I was like, why have I not seen any other of these hummingbirds before? And the reason why is the Annas is the most like common in the state, especially in the Western Washington. The calliope and black-chinned are more common in Eastern Washington. So if you haven't seen them before, that's probably why I'd have to spend way more time there to actually see them. Also, one final fun fact for you before we go into the actual custom vision is hummingbirds are only native to the Americas. So if you're in Europe or Asia, you will not see them. So it's something that kind of makes the Americas kind of special and cool because these are the cutest little birds in the world. But now let's head to our demo. And to do that, I'm going to pull up the internet and go into Custom Vision. Awesome. So now we have Custom Vision open, and I'm just logged into it right now. Give me 1 second to just move my notes a wee bit. Awesome. Great. So now we are in Custom Vision, and this is after navigating to customvision.ai and logging in. As a current master's student at the University of Washington, I get to use my Azure for Students account, so I'm getting to do all of this for free. They give me like $100 credit to do fun work like this. But to actually get started on this, creating an account is super easy. It took me like 5 minutes to quickly make sure my account was still up and running. After you do that, you can go into Custom Vision in particular and click this beautiful new project button. I'll click on that. And then we can create a new project right here. So for our project name, we want to choose something unique. So we'll go ahead and put in a name such as Identify Hummingbirds. Super fun, super unique name. The next up is the description, which is optional, but we'll just put in Identify Pacific Northwest Hummingbirds. We then have a resource, which is kind of where the heck in the cloud is all of these images and this training going to happen. One thing to keep in mind is I already have the resource that exists. So if I click on this, I see this dropdown within my Azure for Students account. We've got this bird vision resource that I've already created. If this is your first time using it, you can click this Create New Resource button. The biggest thing to keep in mind here is choosing like a unique name for your resource, but also making sure that you make that resource located close to you. So since we live on the West Coast in the Pacific Northwest, I put mine into West US 2 as the Azure region. And then after we have that resource selected, the next step here is project types. We see two different options here. We're going to click classification, and I promise you we will come back later to talk more about what is object detection. But here specifically, looking at a single image of a hummingbird, clicking and being able to classify what species is that hummingbird. The next step on this is we've got two options here for classification types. We can do either multi-label or multi-class. The difference between those is if you want to have multiple tags for a single image. In this case, an image of a hummingbird is only going to be one species at any given time. So we will give it the multi-class option, which is a single tag per image. Next up, we have the domains. And this is where it can get really exciting if you're using this in your professional world or for hackathons. Its custom vision has been trained to be super good at identifying different domains of items. So some of these are for example, let's say I had a bowl of fruit and I was trying to identify what type of fruits were in this bowl of fruit. Well, then it would make a lot of sense to click on the food domain because that is a custom vision algorithm that's specifically been trained to be really good at identifying different types of food. In addition to that, we've got landmarks. So if you want to create a custom vision that can identify the Eiffel Tower versus the Statue of Liberty, the landmarks is really good for you. We also have retail, which is super helpful for the retail industry. I mean, different types of clothes, that type of thing. In addition, I'll just quickly point out this general compact. So let's say I was taking images of hummingbirds on my phone, which is this edge location that is not running as much as my big computer. That's a case where the compact would be way more valuable because it's just taking a little small bit, which will just make it easier to run. But then we also have three different types of general. What could that possibly mean? And the way that I found this out as I was preparing this talk is I hopped into the handy dandy Microsoft Azure documentation. And I read a little bit about what is the difference between general, general A1, and general A2. And this one, we'll just click back really quickly. We'll see that it's automatically selected to general A2. What is powerful about general A2 is that it's supposed to work a little faster than the other ones, but also take less training time, which also means that the images should probably look a little more different from each other. If the optimized is general A1 in comparison, is for a more difficult user scenario. So right now, I feel very comfortable that all of my hummingbirds look different enough that the general A2 with the better accuracy makes the most sense. If I was doing something where the species looked just way more similar, pulling out the general A1 or the general of both of these scenarios don't really make sense would have been the right choice. But here, I feel very comfortable with the automatic general A2. I am going to click Create Project. After we load the project, the first thing we have to do is the input data, which, as I said, the most time-consuming part in my personal opinion. And to do this in the background, what are you not seeing me doing is going into your favorite search engine and finding typing in Anna's hummingbird and then downloading every single image that you verify is actually an Anna's hummingbird. To save us from that, I'm just going to pop into a file where I've already created files that include all of these images. I'm going to select all and I'm going to click Open, which automatically opens them. When I do this, also a super cool feature here is that you can just automatically input that all of these images are Anna's hummingbird and add that tag automatically. We'll upload 21 files. Done. It'll take me just a couple more seconds to upload the rest of these. Let's hop into black-chinned, open those, tag them as well. Fab. And then we've got 2 more. I remember doing a demo similar to this like a couple years ago, and it typically took like 15 seconds for these to upload. This is so much faster. So you don't have an awkward silence here, or as I try to fill the space as like these images upload, because it's just so fast, which is amazing. We'll pop in, we'll do our Calliope, upload 22 files, and then last but not least here, we'll pop in and we'll add our final files. Go back into Bird Vision, Rufus, open. Oop, I got to select them all, click open, and tag this. And then we'll upload 20 files, and then we are good to go. So at this point, I already have over 20 images of each of these. And that's probably where the quantity is very much key here. If you had like only 5 images of each hummingbird, when you click this train button, it'll tell you you need more images before we can train this and do an accurate job. In this case, I have over 20, so when I click the train button, it'll automatically start running. At this point, we have 2 different types of training. We have quick training and advanced training. My advice for quick training is, are you just testing out an idea for the very first time and you want to see if it works? Are you at a hackathon and you have 20 minutes before you have to have your project submitted? Are you doing a tech talk and it needs to be over in 30 minutes? Stuff like that is where quick training gets really valuable. But advanced training is, hey, this type of data is extremely important. We need this to be as accurate as possible. In that case, you can click this advanced training, set it for upwards of 96 hours, and get a way more accurate set. I think a handy dandy thing, I actually did this yesterday, is I clicked this little send me an email notification. And after I did that on a different, less complex data set, I like ate dinner, I went on a walk, I came back, I checked my phone and got an email. I was like, oh, it's ready. So I got to go to my laptop and check it out, which was super neat. For this case, we'll do quick training and we'll click train. And now we wait for 5 minutes, but not really, because I already have one that's been trained and ready to go to show you. But just for like your information, when I trained something like this yesterday, it took 5 minutes to run. So you won't be sitting around for a long time going like, oh my gosh, this hackathon project needs to be done. No, it's all good to go. It takes this version very fast to run. And here we see one that's already trained. So after we click that training button, we get this iteration 1, which tells us this is the very first time we've trained this set of data. In addition to that, we've got 3 little graphs here. One's for precision, one's for recall, and one's for AP. And if you remember one thing from this section from the talk, it's 100% is really good. High percentages, extremely valuable. But what do these actually mean? And actually, I wrote like a blog post a couple years ago where I took the time to actually figure them out, because I realized I still need to understand this as well. So what do each of these mean? The first is precision, which is the graph represents how likely your model is to be correct when it detects a tag. So if I upload an image of an Anna's hummingbird, it's saying we're 94.7% correct that this is a correct tag in this scenario. The recall graph represents the percentage of correct tags your model predicted. So specifically going, hey, we've uploaded 1,000 images of hummingbirds, and it predicts that it's going to be correct 94.7% of the time. And last but not least, AP, which is kind of a model that combines the precision and recall at different probability thresholds. But now let's head back into our custom vision. Hummingbirds, this one is even more accurate than in my graph. We've got 100% over all of these. At this point, we can also see the precision, recall, and AP for each tag. For this, it's 100 all the way across the board, but let's not trust those numbers. Let's actually test it for ourselves. And to do that, we'll hop into Quick Test. And here we can browse local files of ones that we haven't tested before and verify them. So we'll pop into my Bird Vision. I've got a handy dandy file for test, and we'll check first with the Anna's hummingbird. This one, 62.7% certain it's an Anna's, so it does accurately predict that it is an Anna's hummingbird. Next up here, we've got browse local files. We'll check a black-chinned hummingbird. This one is even better. It says 91% certain that it is a black-chinned hummingbird. Next up here, we've got Calliope hummingbird. And this one also 92.4% certain. And last but not least, we've got the Rufous, 76.1%. So at this point in time, seeing these numbers, if I were to go back and create a second iteration of this, I would take the time to add more Rufous and Anna's hummingbirds because those are the ones that we're immediately seeing aren't as certain as the other two hummingbirds. Awesome, but at this point in time, let's do something else. Let's kind of test our algorithm with something that's a little tricksy, which I intentionally baked into the algorithm, but we'll just see if it works. So we're going to browse local files again, and then I have this one, which I'm looking for, Rufous female. What will happen here? We're going to click Rufous female, and we see that suddenly it has no idea what's going on. It's 56% certain this is a black-chinned hummingbird. Calliope is 22.5%, Anna's is 14%, and it actually says this last one, 5.9%. What happened here? What did I do wrong when I created it? And what I did and what I intentionally did wrong, and it's just kind of a challenge with identifying birds, is male hummingbirds. That's how we can identify birds, is by their plumage. They're very unique, they're very colorful. Let's look at female hummingbirds of these species. And this is very fun. Let me just minimize this very quick. We'll hop to our next slide. This is what all of the species of hummingbirds look like when they are female or when they're also just a juvenile male. So the Calliope, the black-chinned, the Annas, the Rufous look slightly different, but they're all basically identical. Even professional birders find it extremely difficult to identify different species when it's either the female or the juvenile of the species. So what is the lesson here? This is like my main kind of monologue to you. And what I've learned during this process is really the more the merrier. So the more images you have, but also the more images you put in, you also have to practice inclusivity. And so one thing, Azure Custom Vision, when you first try it out, it typically recommends having 50 images for each tag that you're going to train. But they say real world scenarios can have thousands of images into the system. But if you have 1,000 images of only Anna's male hummingbirds, your program will say, hey, we've got 100% precision, we've got 100% accuracy. But in reality, it's not 100% accurate because I completely neglected to include 50% of the bird species. And that's the part where AI is considered something that it very much, once you train it, it kind of takes care of itself. But that's where us as the humans have a lot of power. Our biases that we have get inserted in the algorithms we create. So it's where we have the most power to go creating inclusive, unbiased algorithms. So that's kind of my big monologue here. We've got, the more the merrier, practice inclusivity. But now let's go to, so that is just a lesson to keep in mind if you're creating your very first custom vision programs. But now let's try it. We're not going to test it with females of the species. We're going to go to a different bird, one that's very in line for Halloween season. It's just around the corner. We've got ravens and crows in the air. So you're probably familiar, if you live in the Pacific Northwest, you're familiar with at least one of these birds, and you might not be able to tell the difference between them because we have a raven and a crow. And so which one, if you live in very suburban areas in Seattle, the greater Seattle area, what you're likely seeing is a crow. And the reason is crows really thrive when they live around humans. Ravens are a little more remote. For example, as I was climbing down Mount St. Helens, there was a raven circling over me for a significant portion of the way, so in a very more remote environment. But how do you tell the difference between a crow and a raven? And I promise you, this is extremely challenging. So the crow, as we can see on this picture, has a much smoother, smaller beak compared to the raven's more robust beak. Another thing to keep in mind about the raven is that it typically has this super interesting kind of patch of feathers on its beak. You'll also see around its neck, the raven's a little more fluffy. Also, the shapes of their tails are different. So if you're looking at a bird from a long ways away, you're probably like, okay, I can probably tell by the shape of the tail. Another thing that I'll just add in to make this even harder for you is The crows in the Pacific Northwest are kind of big. So sometimes I'll see a crow, I'm like, oh my goodness, is this a raven? It's so large. And then my sister, who is the bird expert, is like, oh no, that was a raven. No, that was a crow. So that's kind of like how you tell the difference between these. But let's go into our demo. So this is something that humans struggle with, is identifying the differences between these species. Can custom vision tell the difference between these species? Let's go find out in another demo. So we'll pop back in to it. We wrapped it up with this female rufous hummingbird, but let's go into crows. So behind the scenes, I uploaded 24 pictures of crows and 24 pictures of ravens. Let me tell you, this was extremely difficult. I like checked in with my sister on every single image. I would like type in crow, some are ravens, some are crows. Extremely challenging. But we trained it all, and we have a performance, which is surprisingly good. I ran something very similar 2 years ago, and we were running closer to a 50% precision and recall on the same data. I think the secret of how I was able to get this to perform way better is I used that advanced training where I took way more time to tell the differences between these. So we already see we've got very good precision recall. Same, they're very good for the raven and crow in particular. Let's go ahead and do a quick test. We'll browse local files. We'll go in. I've got some crow vision test images. We'll try with a crow. This one, 92% certain it's a crow. We're doing well so far. We'll try another one of a crow just because. Fantastic. We've got another 85% certain it's a crow. We'll now skip to our ravens for now. Amazing. I love to see it. We are 99.7% certain this is a raven. And then finally, last but not least, we'll test another raven one. And we're also, this one's a little closer, but we're still certain that it is a raven. This is fantastic. I think this is a really good way to go, wow. In this specific scenario, the custom vision, once it's trained to a specific level, can be better than humans, which is super cool in my opinion. I think this is like one of the most exciting things. If there is one thing that I wish I could personally train if I were to go back, is pictures that I take are typically not this good. So could we get these same results with my phone like 1,000 feet away, super blurry? That's the next step for me that I personally like to explore. But now let's do a quick change gears now. We're going to take it through a very kind of fun challenge here. Of like, for example, let's say I'm in my backyard, I have a drinking fountain, and this drinking fountain is so popular with the hummingbirds that I'm seeing multiple hummingbirds in at a single time, and I have to figure out what all of those different species are. So for example, I'll pop back in, PowerPoint. Pop it. Let's say, what if we tried it with an image like this, where tons of different species, even I went to my sister, I'm like, what are these different species? We think there's an Anna's here, a Rufus here, and that might be a Rufus. Even I am not completely sure. But let's now try with custom vision. And we'll pop in actually, but at this point, the one that we trained at the very beginning of this talk is ready to go. So we're going to train it on this one. And we're going to do a quick test. Browse local files. I'm going to find custom vision, bird vision, my test, and then I have this one called lots of hummingbirds.jpg. So we're going to try that. Click open, and then here we are. Our prediction is 75% certain it's an Anna's, but also 16% Calliope, 7.9% Rufus, and it says 0% black chin. But this is kind of like, this is where I'm really throwing curveballs at custom vision just for the fun of it. In reality, this is like asking, like, are you free on Saturday and Sunday? Like, and you just say like, yes. Like, you just like, the response here is not really accurate to the specific scenario. So the challenge here is there a tool that Azure Custom Vision has for these more complex scenarios where we're not just like doing a single image, we're having to identify multiple objects in an image. For example, if I was driving like a self-driving car and it only identified the green light, but not the person driving right in front of me across the way, that would be a problem. We'd get in a crash. It would be extremely dangerous. So does Custom Vision have tools that can solve those problems? And good thing it does. So fantastic. We're going to go back in. We're going to X this out. we're going to go back into our project gallery and we're going to click New Project. At this point in time, we're going to create one. At this point, we're going to do a quick transition from hummingbirds to this is our most farthest away bird, the penguin. So we're going to type in something like identify penguins. And we're also going to enter a project description, identify penguins in an image. We're going to use our same resource here, but now the part that I said I promised we'd come back to, we have come back to it. It is object detection time. So what is object detection compared to classification? And it's looking at an image, and instead of looking at that single image and going, oh yeah, there's one bird in it, it's an Anna's hummingbird. It's looking at a picture where there could be 100 penguins in it and identifying where exactly in this image are the penguins. And this can be applied to any scenario in the world. Like, I think the cool thing about this is even when you bring in different tags into the equation for here's a bunch of pictures of adult penguins, here's some baby penguins, here's some eggs. So this type of use case gets super powerful. Once again, we see this general A1 domain. We'll use that. These other ones even are more specific to object detection. Logos, finding the specific logo in an image, products on shelves. There could be a full shelf at a grocery store with tons of different products, figuring out the specific one. But we'll go and click Create Project. And at this point, we'll add some images I have. We'll go into Bird Vision, Penguin Vision, and we'll just add in one images that I just have and upload one file. And when I was first creating this demo, I was kind of like cringing internally because I was like, oh my goodness, I'm going to have to manually draw boxes around every single one of these penguins. It's going to take me hours. I'm very pleased to tell you that when I came into object detection, it already automatically can tell where certain objects of significance are in the image. So for example, I can like just see this, click it, and type in penguin and add that. And now every single time when I click on an image, I can just click penguin every single time and successfully identify this one. This one is kind of seeing two penguins as one. We'll just fix it here. We'll update this one as well. And then here we can just upload basically all these images and identify the penguins in them, which is super cool. One point that I'll make here is to train an algorithm, you have to do this on 15 different images. So although we no longer have to manually draw them, it's still a bit of a pain to have to go in and tag all of these individually. They do make it much easier now with just automatically detecting where different pieces are. I'll just do a couple more for the fun of it, but then we'll head to an already trained one. Penguin, penguin, penguin. Fab. We've got a bunch of different penguins here. Oh, we've got one more. Great. We'll do that. The images are all tagged. We are ready to go. Now, if I, in a real scenario, I'd go and do this. Oh, yes, we have a question. Yes. That is a really good question. I'm not sure what the answer is, but I will certainly look into it and get back to you. I do remember when I was first creating this, I was going to go all out and create penguin tags, baby penguin tags, eggs, and then I was like, oh no, not only I have to find 15 images with all of these, I then have to add all of them. I mean, in real world scenarios, like there's, especially I'm just taking self-driving cars as an example because it's probably the most easiest for me to visualize. And that one, there's so many things, you need to be able to identify all of them. You can't afford to say, do you know what, this bush on the side of the road, we just don't have enough tags. But I'll look into it specifically for Azure Custom Vision. That's a fantastic question. But so here we've done it. We still, in this scenario, we still have to tag 14 more, but let's pop into an already completed one where I've trained it all. This is also one that I took a way longer time to train. But even with that, our precision is just not that high. 43%, if I want to dedicate the time and really add way more images into it to make it accurate. But with that said, let's do a quick test for the fun of it. We'll browse local files. We'll go into test. I've got two fun images I want to test today. The first one is just a standard penguins staring at some ice in the background. And here we've got this threshold value. And so we've got these predictions. It's got some that are like extremely accurate and others that it's like, unfortunately, this is not a penguin. It's the shadow of a rock, but it's pretty accurate, which is impressive. If I move this threshold value to be lower, it'll start identifying way more things as potential penguins. But if I bring it up to like that 84, 94%, it gets extremely accurate in what it identifies as a penguin. Even like these two that are right next to each other, it's identifying them as separate penguins, which is awesome. But we want to try one more. This is my favorite image from the entire talk. So get ready with me. It's called Selfie. What could it possibly be? It's this extremely intelligent penguin that literally can see the camera and is taking a selfie, which is amazing. And even in this picture, it's identifying a bunch of penguins in the background. I find it very amusing. When I move it down all the way, it starts to identify like, oh, this kind of might be a penguin. I'm sure it's not trained on that many penguin selfies. But with that said, it's pretty accurate. I think in the like very background and the super foreground, less accurate. In this middle ground, way more, but it's kind of seeing a penguin there, which is pretty cool. So with that said, the threshold value just is a super cool tool to use. Awesome, but let's head back to, we're nearing the very end of our talk, which is exciting. But I think the final takeaway I have here is just the power of custom vision, that you can literally apply it to anything that inspires you or you think is cool, which I think is awesome. And I think the additional value of why, like I could technically go into my backyard and identify these on my own. I don't need a custom vision tool to do it. But the power here is custom vision is a great example of using AI to do very repetitive tasks that computers are just really good at. And for example, identifying penguins, I've even done that as like volunteer for work before. It's a very time-consuming process. A computer could do it in literally seconds, leaving us humans to do the stuff we're really good at, such as solving super complex problems. Like, how do we make sure that penguins are still there in 100 years? So that I think is the power of custom vision and why I hope you give it a try and ask yourself the question, what will you build? And with that, that's almost the end of my talk. Some final things. If you're interested in learning more, first of all, you can always ask me. I occasionally tweet about this stuff on Twitter. I have a website where I have some intro blogs on this. In addition, customvision.ai, the link is there. Also, Microsoft has amazing documentation on learning specifically about classifying images in addition to detecting objects with an image, just including so much more documentation. And finally, last but not least, I earned my Microsoft Certified Azure AI Fundamentals certification in January 2021. Literally the best certification, like I'm not even joking, best certification I've earned, super informative, not only for computer vision, but all types of AI. So if this is something you're interested in, that's a really good step to learn more. And with that, thank you so much for coming, and I'll open it to any questions. Yes. Oh, yes.
Microphone working. Yes. Awesome.
Thanks. So I was just going to ask, you uploaded, like, you clicked the little quick test button and then uploaded images, and you could see, you know, the results and stuff. I know on a lot of AI, just not it kind of more code intensive examples that I've worked with, there's the possibility to create a test batch that you don't train the AI on, and then you test it on to make sure that it isn't overtraining, you know? So is there kind of like a system to do that automatically, or do you just have to kind of check it, or is that kind of something that you have to read through the documentation a little bit more densely for?
I would 100% recommend reading through the documentation a little more. Like in my world, I just like have like three different, I have like my files. I have the tagged ones and I have my test ones. With that said, there's probably a way more optimized way to do it that I'm not even aware of. So I highly like, that is my personal recommendation. And it might exist, I'm not sure.
It does go if you into the performance tab.
Amazing.
Yeah. So when it actually works out the values, it does use a small amount of the data, I believe, to actually test. I don't know how much that would be in the docs. Another thing you could do is there's an API for all this. So if you wanted to actually build a more structured training and testing methodology, you could then just use the API to, here is my training data, train it, here is my testing data, use that to do an assessment.
Is it possible to give this real-time data rather than static pictures? So you
Yeah.
get like a stereo vision or a LiDAR or something so that it's interpreting stuff on the fly?
Yeah, 100%. It's definitely possible to give it live data. I've even like in hackathons done live things where like we created a website, we uploaded a photo, and it could immediately spit back like, hey, we're pretty certain that it has X thing. So absolutely possible in it to do live predictions even. I think even, yeah, like you start going into like kind of the API side of it, yes, possible.
Example, so you get cool. Any other questions? So the question process. So when this runs, it uses whatever resources have been allocated to run this. So this isn't, but you can export these models, and then you can run those models on your own kind of then up power you want to throw out. Here, if you run it like an NVIDIA Jet, you would get probably, I mean, maybe not second, but you might get 7, 8 more hardware you throw at it, the more. But yeah, the idea behind this is an easy way, easy-ish way to train, and you can get. And if you want to, you can export these models and run that on whatever. Cool. And any other questions? I have one question. Oh, another question here. That's not this. So behind this, uses thing model that's already been built, but just had the edges trimmed off, and it uses that technique. So you can't bring your own models into this. That things you've got your own model, you could, but then write your own code to retrain it. So yeah, no, great question. What's your hummingbird?
Oh my gosh, it must be the Calliope. Like if we're going specifically Pacific Northwest, Calliope, I feel like there's some that I don't know the name of. And thank you so much. That's a great question. They have like the most outrageously long beaks in the world, which I just admire them for that, to like reach into like the most like very intense flowers. So I think like in the Pacific Northwest, Calliope, I'd love to see one day. That's like, that would be very cool. But great question. What's your favorite hummingbird?
I have no idea. I'm just aware there's hummingbirds. I've not actually seen the differences. So yeah, I can't comment.
That's
doing this or after?
such a great question. I think I liked them beforehand, but then even the funny thing is, like I was like thinking, and this was like a while ago, but I'm like, what should I create just for the fun of it, for like trying to learn more about it and teaching other people? And like you go into customvision.ai, it has the same image it had when I first tried this thing like X number of years ago, and it's of a hummingbird. So literally, I saw the hummingbird. I was inspired. I was like, oh yeah, this would be a great idea. Did this huge launch into Pacific Northwest hummingbirds. So I think I mean, how can you not like them beforehand? But I definitely am like, now I'm an expert on Pacific Northwest hummingbirds, which is a cool side effect.
Awesome. AI and ornithology in one. Can't get better than
Yes.
that. Cool. And any other questions? No, okay, with that, thank you very much. Thank you very much, Locksley. For the people who watch the video, thank you for joining us. We're going to stop the video now. For the folks in the room, we have pizza.
Woo.
So if you want to take a wander through, drink, grab pizza. We have more than enough pizza. So there's any left when we finish. Feel free to take pizza home. We have vegetarian, we've got salads, we've got gluten-free, meat pizzas, and I think we might have the brownie cookie thing, which is horribly bad for you. But thank you, everyone, and thank you, Locksley. Round of applause for our great presenter.